Hi guys, welcome back to my channel. So in this video I'm going to go over double integrals and I'll be solving some simple problems of double integrals. If you want me to solve complex problems, then do watch the next part of this video. I'll provide the link in the description below, or you can check it out in the playlist of the Calc3. Okay, let's get started with this problem. So here we have a double integrals problem over here. So for this you need to understand that you have dy dx, right? So here the dy is associated with the second integral. Okay, so dy, the y values belongs to this integral, and here you have dx, so the x values belongs to this integral, the first integral. So it always works like that. So you have like an inner part and then you have an outer part. So this is how you're gonna solve it. So you're going to break this question into parts. So we always work from the inside to outside. Okay, so first we're going to split this into two parts. So this is the first part, and then we're going to take the next part, which is this part, the dx part, and then first of all we're going to evaluate for this integral. Okay, and then whatever answer that we get from here, then we're going to take that answer and integrate it with respect to dx. Okay, so I hope that makes sense. If it doesn't, don't worry, when I'll solve it, it will be clear. Okay, so first of all we are taking the inner part. Okay, 0 to 2 x plus 3 dy. For now, let's just forget the outer part. Okay, so we're on, this is like a simple problem that we had in Calc 2, right? We only have one integral. Okay, but yeah, this is a multivariable problem since we have multi-variables over here. We have x and y over here, so we're integrating with respect to y, right? So that means we're treating x as a constant. Okay, so here the x is a constant. We're going to put a y in front of it because this is how we do integration with the multivariable. Okay, and here this is a constant well, so we are going to put a y next to it, and then from 2 to 0. Okay, and yeah, we're going to solve it in a minute. Okay, but before that, you don't have to please don't forget the dx and from 0 to 1, because some teachers are really picky about the notations, so you always have to put them even though you're not using them. So just to indicate that it's a double integral problem. Okay, so as like you can do it like you solve this question first, and then you're going to add these at the end. This is what you can do. Okay, so here we're solving for this one. So we're going to plug in y equals to, but why? I mean, why do we put a y over here? Because here we had dy, so these y values are associated with the y, so we're not going to put it x. So you have to write y over here, otherwise you will confuse that whether to put this 2 into the x variable or the y variable. Okay, so let's solve this. So here we are going to have 2 plus 3, and then we have to put 2 and then minus, and this is gonna be 0 when we're going to put it to 0. Okay, now let's solve this. So that's 2x plus 6, and then so here we're gonna have this. So we're gonna have this. So this is the answer to the pink integral, the dy integral. So now once we have the answer to this, like I explained before, we're going to take this answer, and then we're going to differentiate it, integrate it with respect to dx. Okay, so we're taking the dx over here from 0 to 1, and yeah, don't forget to write it at each step. Okay, now we can finally do the dx part. So this is only one variable problem, so here we only have dx and there's no y over here, so simply we are integrating like normally. Okay, and then 6x since it's a constant, and then from 1 to 0. Now it's simple, just plug in the values 1 and 0. So 1 squared plus 6 times 1 and then 0. So this is going to give you 7. So 7 is the answer to this double integral. Okay, let's solve the next problem. Alright, this is our second problem. So like I said before, first we're going to split the question into two parts. So this is one part and the dx is the next part. Okay, so first what do? We evaluate the inner function. Okay, the inner part. Okay, so this is the integral from 1 to 4 xy dy. So first we're evaluating the dy integral. So this is dy, that means the x is treated as a constant over here. Okay, so that's it. This is going to be 4x. This 4x stays over here because it's a constant, and then we're going to make it y squared, over 2. Okay, and then evaluate it from 4 to 1. Okay, and then first let's just solve this, and then we're gonna worry about the dx later. Okay, so now let's just plug the 4 and 1 into this equation. So here you can simply factor out the 4x2 over here. So 4x over 2, since these are constants, so you can simply factor them out. And 4 divided by 2 is simply 2 over here. So you can just factor out the 2x, and then you're left with y squared. Okay, so then you can plug in the y equals to 4, and yeah, you always need to remember to write y equals to 4 and then y equals to 1. Always remember to write the variable that you just differentiated with. Otherwise it will create a problem for you later because you have two variables over here. So yeah, just to make your life easier, always write the variable. Okay, then we have y equals to 4 and y equals to 1. So we can put 4 inside and then minus 1. Okay, so if you evaluate this gives you, okay, so this is 16 minus 1, which is 15 times 2, that's 30. So 30x. So this is the answer to the pink part, remember? But we're not done yet. We still have the blue part left. Okay, so for this we're going to write the dx with everything that we solved so far. So you always need to write it because you need to write the dx at every step that you do. But writing it while solving the problem, it gets really hard, so I always like to do it at the end. Okay, and now finally you can solve for the dx from 0 to 2 dx. Okay, so here this is like a Cal 2 problem. It's really easy, one variable. So 30x squared divided by 2 from 2 to 0. And here you can simplify it, 15. So 15x squared from 2 to 0. Now plug in 2 and 0 inside. So 15, 2 squared minus 0. So this becomes 15 times 4, which is 60. And this is the final answer to this problem. Okay, let's do another problem. Alright, so this is our last problem for the video. So like always, we are splitting the problem into two parts. So first we are evaluating the inner part and then the outer part. Okay, so here first we're going to write from 1 to 3 xy squared dy. You can always write it all together. If you can manage to do it all together with the dx in front, then go ahead, you can do it. But I always prefer to do it like this way because it's not confusing. Okay, so now we are differentiating. We are integrating with respect to dy, which means x is a constant over here, so x stays over there, and we are just simply going to cube this and divide by cube. Okay, and then we are evaluating from 3 to 1, and yeah, not forgetting the y because it's dy, so it is the y value, not the x value. So y equals to 3 and y equals to 1. Okay, now let's solve this. So x over cube, these are just constants, so we can just factor them out, okay, and write it like this, okay. Now our job becomes easier, and now we just need to plug in this one, okay. The last one, I just skipped this step and directly put inside, so I'm just writing it in here. So because I skipped in the last part, so for those of you who don't understand it, you can simply understand it from here. Okay, now I can put the 3 inside the y, so that's 3 cube minus 1 cube, where 1 is the same thing. Okay, so this is 27 minus 1, which is 26, so it becomes 26x over 3, and this is our answer to the dy. But remember, we are not done yet. You know what? I would always forget that we have a dx over here, and I would forget this, and I would simply write, this is my final answer, and I was always wrong. So I figured out that I need to put like a symbol over here every time, so that I remember that I still have the dx left. So you know, in the exams, what I would do, when I'm doing the dy part, I would put like a star in here to know that I still have this part left. You can put a star over here, or you can put it over here to know that you still have dx left, okay. And once you have done it, you can simply cross it out or erase it. Okay, so yeah, so we have the dx part left. Okay, so simply writing the dx everywhere. So 0 to 2 dx, 0 to 2 dx, 0 to 2 dx, and now finally over here we can evaluate it with respect to dx. Okay, so dx, this is where going to add 1 to it and then divide by the exponent. So 3 times 2, which is going to be 6 at the bottom. Here you can do it like this, but if you're confused when there's a fraction like this, whether to multiply or divide, you can always convert it into decimal and then divide by 2, or you can do something like this if you want. It's 26x over 3, and then you can divide by 2, okay, like this. You can also write it like this. If you put this in the calculator, it's gonna give you 26 over 6, which is equivalent to 13 over 3. But if you want to solve it manually, you know, dividing by 2, because here there's nothing at the bottom, right? So it's like 2 over 1. Dividing by a number, the dividing fraction, it's same like multiplying by the inverse of it. So you can always multiply it by 1 over 2. So that's 26x squared over 6, right? So I hope this makes sense. This was just aside from high school, if you were having difficulties with this. Okay, let's get back to the problem. Okay, so that's 26x squared over 6 anyway. Okay, and then 2 over 0. Okay, and then this is, if you simplify, that's 13 over 3 x squared, 2 to 0, and then plugging in the 2 inside it. So 2 squared minus 0, which is 4, and 13 over 3 times 4 gives 52 over 3, and this is the final answer. And you have just done it, and now you can remove the star. And thanks for watching. Bye. You can always find the notes in the description below, and do check them out. Bye.